I'm Bruno. I'm SRE at MaxMilhas. I came here to talk a little bit about our NGINX implementation and how that solution could help us to solve some problems about application delivery. First of all, I would like to tell you about who we are. MaxMilhas is a Brazilian startup. We was founded in 2013. We built a flight booking platform where people can find the best fare combinations. Our platform allows people to compare different company prices and find the best ones. MaxMilhas makes it possible because we connect people who want to travel and people who desires to sell their miles. It's about our challenge. Uh, in US, as in US, in Brazil, we also have Black Friday. In MaxMedia's case, we have another important day that's known as the World Miles Day. That happens every January 6th in Brazil. That's our birthday. These 2 days represent the most important days in sales and volume of access in our platform. And month after month, we have been breaking some records in traffic in our applications. And so we had a challenge. We had a challenge to handle a performatic platform able to support a high volume traffic that you have been expecting, or maybe that you have never been expecting. And you face some problems. We need to discover some meters about our applications. We knew that we have some difficulties. We need to deal with some uncertain conditions because we didn't know how much traffic we will receive. We didn't know if our partners, we are intermediate website or platform, so we didn't know if our partner applications will support our traffic, their traffic, and all other players of the market traffic at the same time. And today we heard from Gus that the software is about people, code is about people. We need to deal with some expectations. We need to deal with expectations about the company, about the coworkers, with the market, with our customers. We have a challenge to improve the user experience, mainly for the first-time users. And you need to deal with the legacy part of our systems. We have some stats from our application that we collected. We reached in the event more than 15 millions of requests per hour in the peak hours. It's an important metric to us because usually we have been receiving 10 millions of requests per day. And in that day, we reached in 1 hour an equivalent traffic to 1 day and a half. And that's what's the beginning. We need to reduce the uncertain scenery to us. We choose to make some load tests against some applications to measure our weakness, our bottlenecks. We used the framework Locus to create the load test scenery. And we deployed no more than 4 nodes to create a stressful chaotic scenery for our sensible applications. And I doubt that some of you can happen. What can guess what happens when we place the first load test in our environment? Can you imagine? Lots of dance. I was worried, and we have a big problem to solve. And the word said we have few time. I go ahead to not make well to someone. And what can I do? So we have lots of applications. We have something about 30 microservices, one big monolith. We need to understand the behavior of each critical applications. Why did they go down? What's the access metrics of the apps? What's the desired response time? Understand the input and the output payloads for each applications. what's the output changes frequency, and what's the impact if I decide to reutilize some contents for some time. So we stood in detail each critical application, and we designed a plan that involves lots of things, and between that things involve that actions. We decided to implement HTTP level cache. Until this moment, we have no solution with it. We decided to implement server-side includes. We decided to implement some throttling layer, and we noticed that we have lots of bad bot traffics. We decided to integrate our platform with one partner called Perimeter X to help us to control the bot traffics against our applications. So we measured some key queens, and the major of them is we decided to cache all the things as possible, at least one of the most important applications. And I know that seems a liar, but we deployed a cache layer in front that application. You could get more than 99% of cache hit. That's a graph about the number of requests when we made the deploy. I was worried because I think that something was wrong, but it's true. We have other profile applications each get the standard metrics between 5 and 8% of cache hit. But that caught my attention because I have never seen nothing like it. That application calculates the boarding fee and have a few input and a few changes about each airline in the world and about each airport. So we have a regionalized access, so we could get in-person tax of reaching the cache hit. That's the initial environment of the most part of the applications. We can see initial environment with a traditional load balancer with EC2 and AWS. It's not so resilient or scalable. And we designed a new proposal. And as you can see, we designed an improvement and solution that improved the resilience to support a large scale events. We create a edge layer using NGINX Plus in front of our internal load balancers, and integrate the Cloudflare layer with Perimeter X using the Cloudflare worker scripts. We choose to use NGINX to manage cache layer because we noticed that with NGINX we have more flexibility in the solution to manage the cache parameters using, for example, personalized cache keys. We also can work with SSI and can create personalized throttling. We choose by flexibility. Here we have some log tips about troubleshooting. It's an important topic if you need to set up the right log format for your application. NGINX Plus have a special variable request ID that represents a random value for each request. It recommends to log it to easily find the log line related with the problem that you are working on. The variable time represents the time that the request finished. And NGINX set some variables based on the request, like the arg underscore the name of the query string. You can access the specific value for the specific query parameter that you receive in your request. The same for HTTP readers. You can access the specific value of the readers in the variable HTTP underscore the name of the reader. And the same thing for cookies. Cookie underscore the version of the name of the cookie. You just need to pay attention to avoid log private data. Other important things to log. You have some upstream informations about the address of the server that processed that request, the cache states for that request, if it was miss, it's on hit, it was an expired object delivered, have informations about the connection time, header time from the upstream, the queue time if you use some queue to control the traffic to send to your upstream servers. And now we talk a little bit about cache. Now you have an example request URL, and you can understand a little bit more about the vars configured by NGINX during the process of a request. We have the arg variable that represented by the args variable that represents the entire query string sent by this URL. As you can see, you have all the values, all the parameters in that variable. And we also have the arg underscore the name of the query string to access the specific value for the specific query string. To access the specific cookie or specific HTTP header, you have the specific values too. As you can see, you have in that example the version in the cookie, and we have other headers content type to access one specific header for that request. Why that's so important? Because with that, if you can understand the scenario of your application, you can define one proxy cache key more efficient. You can avoid to give the opportunity to some parameter that's not so important for you, bring your cache hit rate to a bad stats. Oh, stay a little bit small. I don't know if you can see, but I can talk about proxy cache path. As you can see, you are using shared memory. I don't know. Everyone can see? Okay. It's important. It's recommended to use the memory to store your cache objects. Of course, that it depends about the volume of your storage size by cache. It's about budget and other things. Sometimes for media, videos, and other things, it's not so possible. In our case, we are talking about some REST APIs, and we can do it. The native parameters set the time that an object can stay in the cache before they be recycled by the cache manager process that runs continuously. The cache manager process recycle the object that has not been used. So if you have an object in your cache and they was not been reached for that time, the cache manager process can recycle that object. We are using connection pooling by the connections that set the HTTP version and the proxy set header connection to avoid to do lots of times the TCP run shake process. We are using the proxy cache lock to avoid concurrent requests in the same proxy cache key. If you have a very popular object, it's important to enable it to avoid your fleet of servers to process lots of time the same object. So when you enable it in NGINX, just allow one request goes to the upstream servers, and they delay the other requests, waiting the response for the first request, so deliver that request to all the customers. It have a timeout about it. By default, they wait for 5 seconds the request until they deliver the request to go to the upstream server. We configured that NGINX to use the stale versions. It's important if you need to deal with some outage in your upstream layer. You can work with the old versions of some objects. Sometimes it can be important. It works. You need to have in native time greater than the time of your cache valid. So if you, in that case, we have 2 minutes for proxy cache valid, and you have 4 minutes for inactive objects. So if I have one object with 3 minutes old in the proxy cache, they already old, but they can be used by NGINX to respond some requests if you have some problem about that errors, timeout, HTTP 5XX errors, and other things. We configured NGINX to execute the background updates of the cache to enable NGINX to deliver a pseudo-old version of the file and refresh it immediately from the upstream. How it works, you have an object in the cache, the customer sends a request, this object can be stale, you respond that request with the old version of the file, and immediately you made a background request to the upstream to update that version. It's possible to work for us because we use a short time for the TTL of that objects. Sometimes you can use a larger time, or sometimes 2 minutes, a lot of time for you. And if you have a high popular application that needs to deliver the fresh version of the file as soon as possible, or you can use a proxy cache valid in seconds. You can use the leash value is 1 second, or you can just ignore that parameter and control the cache lifetime in the application side, just to instrument your application to send the header cache control with the age, with the number of seconds, and NGINX will respect it by default. You can disable it. And the proxy cache key, in that example, you have a scheme that's related with the protocol, HTTP host, the URI, that's the variable without the query string params. And here we are using one arg, that's arg product ID, and one header, that's the header, the HTTP header partner ID. What's so important? If this server this NGINX receive a request with other parameters that's not so important, they will ignore it and use the version from the cache. If you use a request ID, some char that changes in the request will get us a miss in the cache. So it's important. I already have an experience in the past when I have an application that's configured by default using the default proxy cache key with request URI, and that application receives traffic from Google Shopping. It was Black Friday too. And Google Shopping appends in the URL one query string called gclick that contains a unique ID for the Google, but it does not represent nothing to change the output of my application. But it's impact in the cache hit rate. And of course, it's impacting the processing performance, and sometimes, depending of the amount of traffic that you are receiving, you can stay in a problem if you are using the request URI. You need to analyze it's the good choice to use the default option, or if you can be more precise, more specific in your cache role, it can make the difference for you. A little bit about throttling. NGINX offers an efficient feature to control the incoming traffic. You can use it together with geo and maps to create a powerful and flexible traffic control solution. The most part of the CDN can offer something to control the volume of the traffic, but sometimes they just set an amount of requests that you receive. You can't be more specific about resource, about method, and about other things. With NGINX, you can set it by method, by token, by HTTP header, by whatever you think. So in that example, it's a simple example that I got from the NGINX website. You have a limit request zone that set 5 requests per second and a limit request inside the server with one burst of 12 requests. And it starts to delay the requests after the 8th request. So you can see that the first 8 requests working fine. From the 8th onwards, NGINX starts to delay the requests until the 12th. After they start to block the requests inside that time window. So based on the number of requests per second, NGINX can control the traffic against your application and can delay it to avoid your application goes down or have some other problems about performance and impact other user, of course. So here I have an example. We are using the model RealIP to change the remote address variable because the topology that I chose, we have one layer in front NGINX with load balancer, with CDN and other things. So the remote address that reach us is the remote address of the Elastic Load Balancer of the AWS. So we use the RealIP, and based on the header X4.4, we get the RealIP of the customer. And here I use gel to make a IP address match and set the whitelist variable with 0 to the default value, and if it have a match, it will set to 1. That means that I would like to whitelist that customer. And in that example, I have a map using the whitelist variable and the request method. I configured 2 variables to limit the request, the request method get and post by different ways. I set 2 limit request zones, each one with just one request per second, as you can see in the first lines. And in the server scope, I configured the limit request to allow a burst of 4 for get and just 1 for post, and we have no delay. So what happens in that scenario? If you receive in the same second 3 requests with the post method from the same IP, and it's not listed, this IP is not listed in the GL whitelist that I showed in the previous slide, the first request will pass, the second will pass by the burst condition. I was allowing just 1 burst, and the third will be dropped. Some tips: pay attention about the log sequence. Times about the time that the log was populated and the finish up of the request. And the request times about the time is the amount of time spent to process that request. So it's important because it's common to, when you are analyzing the logs, to see the blocked request lines before to the accepted request. And if you forgot, you can be in a bad situation, especially if your application spends some seconds to process, because it's faster to block than process the request. And you can use, and I recommend to use maps to set different variables and configure specific behaviors for different methods and conditions. And finally, SSI. It's an example. Basically, we use server-side includes to split some parts of the content that we have in a private scope from the other part that's in the public scope. Based on that segmentation, we can deliver the content and render the main request from SSI and configure different behaviors for its resource. As you can see, we have two routes in that example, the homepage and the My Account box. The homepage, of course, is a public information, and My Account is about personal information. Our backend sends an HTML comment informing NGINX to make a sub request to that route. As you can see, that request is just allowed to the NGINX, just allowing the local host to make that request. And we disable the cache because SSI cannot deal with it with compression. So, as you can see, the internal route is just processed in a normal way, but it's a sub request. And SSI render that content of these two requests together and create a unique response to the customer. So it's fill the part of the content with some other information. This approach allows to cache the public content and decoupling the private content. You can sometimes do it segmenting different cache times for one page that's totally coupled. So here I have a diagram about how it works. The user once sends a get to the home page in NGINX. It does not have that content in the cache, so it sends the request to the upstream server. The application processes the request and reply the home page with the cache control age configured in 5 minutes for the cache of that object. The NGINX receives that response from the upstream, process the SSI instruction, and make a sub request to the application server to process the route to My Account. The application server processes the My Account, reply the content with the cache control private or no cache, because it's a private content, it cannot be cached. NGINX render it together and deliver it to the client with the cache status miss. After that, the orange user send the request to the home page. Now NGINX get home page from the cache because it's already there. Process SSI instruction and make a sub request to the application server process My Account box for that new user. The application server reply the content with the cache control no cache, because it's a private content too. And NGINX render it together and deliver it to the customer with the cache status miss, so we could save the home page. Okay. Thank you, folks. Thank you, NGINX. Thank you, MaxMilhas. We will fly together lots of times again.